Hello, and welcome to this demonstration video of Codeware's compressed software. Today I'm going to give you an overview of the compressed software and what it can do for you. Let's get started with a new vessel. In order to do this, I'll come up to the File menu, I'll select New, and I'll select a Division 1 vessel. This is going to open up a blank document. This is our modeling screen. This is where you, the user, will either model your entire vessel or a simple component. For example, if you'd just like to check the thickness of a head or a cylinder, you could simply model that component and run the code calculations. Now before I get into the modeling, I'd like to get your attention down to the bottom right hand corner, where you'll see Design, US, Div 1, and 2013. This is what we call our status bar, and this just has some of the options that are available to you in each compressed file. For example, if I right click on any of these, for example with Design, options appear. So you'll see we have an option between design mode and rating mode. Now these are the two modes of operation available to you in Compress. Design mode is meant for new design work, fabrication work, where rating mode is really meant more for a re-rating of existing vessels, or if you'd like to perform a what-if analysis. Next are the units. This file is currently set up to use US customary units, but we can also change it to metric if we choose to. We also have Division 1 and Division 2 available for the user. And finally, we have the latest code edition, which is the 2013 code edition. All previous editions and addendas are always available to you in the latest build. This is very helpful if you're re-rating vessels, because this allows you to use our latest software without having to keep older installation files around. Let's get into some of the modeling quickly. I currently have this vessel set up to be modeled as a vertical vessel. If we need to change it to be horizontal, what we'll do is we'll simply go to the Action menu and we'll select the Set Datum option. Once the Set Datum dialog appears, we can change this to be a horizontal vessel if we wish. But we're going to leave it as a vertical vessel. With vertical vessels, Compress models them from the top down. We do this so that we know how much weight will be acting on the supports once we get to that stage. The suggested modeling approach is to model the main chamber first. By this, we mean the heads, cylinders, transitions, main components like that. Then we'll add any internals we may have, followed by the supports, nozzles, and any attachments we may have after that. So let's start with our top head. So what we'll do is we'll come up to the component menu, like so. Now this component menu has all the pressure retaining components except for the nozzles. They get their own pull down menu that we'll get into in a little bit. So what we'll do is we'll first select the first head that we'd like to use, whether it's an ellipsoidal head, an F&D head, hemispherical head, maybe a dish cover, or even a B16-9 pipe cap. So we'll take an ellipsoidal head. Now with all of these components, there's going to be at least two dialogues associated with them. The first one that you see will fill out things like material selection, design pressures and temperatures, some material options, as well as radiography selections. So the first thing we'll look at is the material. So what we'll do is from the pull-down list, we'll select the material that we'd like to use for the construction. We'll just use SA 516 grade 70. And now we can move on to our pressure and temperature inputs. Compress looks at internal and external pressure separately. And we work in gauge pressure. So anytime you see PSI, this is PSIG. So what we'll do is we'll simply type in the pressure. We'll design this at 200 PSI at 300 degrees Fahrenheit. And we'll enter in 15 PSI for the external pressure to simulate a full vacuum condition. Then what we'll do is we'll add any corrosion we may have on this vessel. So I'll type in a 1/16 of an inch, like so. And this will get added onto the required thickness, which we'll touch on in the next screen. Then what we're going to do is drop down to the middle here, and on the left hand side, I'm circling around two options right here. The first is the MDMT. This is the minimum design metal temperature. Now this is what I consider to be a target MDMT. So this is what we're trying to design the vessel to. Compress is constantly running calculations for you in the background. So we're trying to get to -20. However, if a component, maybe a nozzle assembly, is only good to -10, Compress is going to alert you. The next input is the test at input. The test at input has to do with the hydrostatic test. One of the checks that Compress performs is we ensure that the metal temperature is warm enough to meet the code requirement per UG99H. So if you're in a northern climate and you're testing during the winter months, we'll need to make sure you get that temperature in there. Okay, we're going to jump over to the right here, and I'm circling around a couple options. I call these material options. So impact tested, material normalized, produced to fine grain practiced, post-welt heat treating performed. These are options that may not be known to the designer at the start of a design. Since Compress is constantly running calculations in the background, we can determine if any of these are mandatory for you. For example, if we were to design at a very high pressure and a high temperature, and we come to the conclusion that the required thickness is over 1.25 inches, normalization and post-welt heat treating do become mandatory at that stage. So what Compress will do is pop up a little warning for you, and we'll turn these options on. However, you as a designer can also optionally turn these on if you'd wish. We can also choose to use Code Case 2695 on this component, which allows us to use the new Division 2 rules, but with Division 1 allowable stresses. Finally, we're going to take a look at the radiography. Now we'll need to specify the radiography for the longitudinal seam, as well as the circumferential seam. Since this is a 2-to-1 head or an ellipsoidal head, most of the time they're going to be seamless. So you would select seamless on the longitudinal seam selection. But we're going to weld the next component on. We'll need to let Compress know if we're planning on doing a full X-ray, a spot X-ray, or none. Based on this selection, Compress will look up the joint efficiency for you, and will also determine the RT marking that will get stamped on the nameplate. So we'll take a full X-ray here. So everything here looks good to me, so what we're going to do is click Next. And we're going to come to the second page, and this is the geometry selection. So the first thing you as the designer need to do, you decide if you'd like to specify the diameter by inside diameter or outside diameter. Now I'll leave it as inner diameter, and I'll enter my diameter here. I'll leave this as 60 inches. Once Compress gets this value, now we have all the information we need to size the minimum head thickness for you. So then we come to the minimum head thickness. And one thing to note about this input is that you'll see a black text beside the input box. Anytime you see this in the program, this is a calculated minimum value. So this is where our design mode and our rating mode differ. In design mode, I wouldn't be able to put in a value lower than this. If I was in rating mode, I would be able to put a value in lower than this, and I could derate the MAWP of the tank. So you as the designer will look at this and say, well, maybe we'd like to bump it up. So let's bump it up to the next commercially available size. And we can do the same thing with the straight flange as well. Once we get to this point, what we'll do is we'll click OK, and Compress will model the head for you. So we can move this head around, we can rotate it, things like that. Okay, now that I have the head done, we can now move on to the next component, which in this case is going to be the cylinder. So again, what we're going to do is come back to our component menu, and we're going to select cylinder. Now one thing you may notice here is that all the inputs were the same as they were on the head. Now instead of typing in the information again, what we can do is we can copy the information from the head over to the cylinder. All we would do is click the copy last button in the bottom left hand corner, and you can see our pressure and temperatures have been brought over. The only thing I'm going to change here is the longitudinal RT, and I'll change this to full. We do have an option for you in Compress to do this automatically, but sometimes designers are designing multiple chambers that see multiple pressures and temperatures, so we give them the option to enter these in. So we're done here, so what I'll do is I'll click Next. I can review my shell length and my thickness. And one other thing we can do here is we can add multiple cylinders at once. So you don't need to model a cylinder at a time. Let's say we need to add 3 shells here. Well, what we can do is in the number to add box, we can enter 3 here, click OK, and 3 cylinders will be added for us, like so. One other thing that you may notice here is that we've built these cylinders out of a plate material. So these cylinders will need to be rolled and welded. One thing Compress will do is place longitudinal seams on the vessel for you. Now you have full control over these, and if you'd like to move these, once these seams get placed on the vessel, a long seams button will appear in the top left hand corner, and when we click on this, you can see a 2D shell layout of the seams. And once we start putting nozzles, clips, and lugs on here, they will show up on this so we can try to move these seams around these other components. I'm going to go ahead and finish off this bottom chamber, but instead of going to the component menu, what I'm going to do is use my shortcuts here on the right hand side. So I'm going to hover over a component. You can see this is my ellipse saddle head, so I'll click on it. I'll click copy last to bring the information over. Then I'll click next, click OK, and there's my main chamber done. So just to reiterate, we can run calculations at any time during the modeling process. So for example, if you'd like to run the calculations to maybe determine the chamber MAWP, we can do that. However, we're going to continue on right now. So the next item I want to touch on is the internals that we may have. We want to get these modeled first so that, again, it's accounted for in the weight. One in particular, the internals that we may want to consider is a liquid level. Compress automatically considers any static head acting on the vessel. So in order to model this, what we'll do is we'll come up here to what we call our loads menu, and we'll select liquid level right here. Now in this dialog, we just need to know a couple basic things. We need to know if you'd like to fill the liquid all the way to the top of the chamber, or if you'd like to fill it to a specific point above the datum line. And our datum line is taken from the XY plane right here. So let's fill this up to 150 inches above the datum. And then we just need to know the specific gravity of the liquid. So we'll just keep it as 1, so we'll assume it's water. And when we click OK, you'll see an LL line up here. This is our liquid level, and it will also appear up here as well. Next on the modeling list would be the supports. In order to add any of the supports, what we do is we come up to the support menu right here. And you can choose to place this vessel on a skirt. We can choose to place it on saddles, legs, or lugs. So let's go ahead and put a skirt on this. So I'll select skirt, and I'll select the support skirt. Now with the supports, we just need to know basic information. Starting with the material, the top and bottom diameter. Compress gives you the option of flaring out the bottom diameter if you'd like a little bit more stability. The overall length, and then the nominal thickness. I'll just bump this up here. Once we get this information, what we can do is we can attach a base ring to this skirt, we can start adding skirt openings, or we could just simply add the skirt. So if I clicked OK here, you can see here that the skirt has been added. But what if I would like to go back and make any changes to the component? How do we edit components in the program? In order to edit a component, what you'll do with your mouse is hover over the component and right click with your mouse. And then we'll select the component that we like to edit, and the dialog will reappear. So maybe at this point I'd like to attach a base ring. So I'll select the option attach base ring, and I can work my way through the dialog. Now Compress has some intelligence built into it. So we know this is a 60-inch vessel, so we're going to start the bolt circle at 65.25 inch. With any of these values, you as the designer can change them, but this is really just a starting point to give you a working model. So really what you can do is you can change the information here, or you can just work your way through your dialogues, let Compress size everything for you, and then come back and change anything. So I'll just click next here. Again, we'll size any thicknesses that you need, and I'll click OK. And there's my base ring added. The last item I'd like to touch on with the modeling are the nozzles. Now I told you before they're not included in the component menu because they have their own menu. So up at the top, what you do is you select the nozzle menu. And I'll select to add a detailed design here. Now this is our nozzle dialog, and this is set up a little bit different than the other dialogues that we've seen because we have more options available to us. So the first thing that we'll need to do in the top left hand corner is select which type of nozzle we'd like to add to this vessel. Types 1 to 4 are going to be pipe. Type 1 would be a set-in nozzle, it's flush to the ID. Type 2 is the same but it has a reinforcing pad. And then 3 and 4 are similar, but they have internal projection. And then 5 to 8 are going to be set-on nozzles, like small threaded couplings, things like that. And then types 9 and 10 are going to be heavy barrel forgings. And 11 and 12 are going to be stud pads or pad flanges. What we're going to do is we're going to take a type 1, and I'm going to leave this as a nozzle. And then we can choose to make this radial, perpendicular, or hillside. So if we need to offset the nozzle, we can do that in compress. What we're going to do is make it radial, and we can now move on. Then what we're going to do is just drop down, and we can change the drawing mark in the identifier. So if this is an inlet nozzle, an outlet nozzle, you can name it whatever you'd like. Then we simply select the material from the pull-down list that we've seen previously. Now at this point, what we can do is we can attach or add our flange to the nozzle, or we can size the nozzle neck. It's really up to you. Some designers choose to size the outer diameter first, so what we can do is drop down here, and we can size it. Now you can type in your own outer diameter and your nominal thickness. Maybe you have an odd shape that has to be rolled, like a 13-inch nozzle, things like that. But if you're ordering standard pipe, what we can do is click on the standard size lookup button right here, and this will open up Compress's pipe library, where we can look up pipes, threaded couplings, and even studding outlets. So we'll select pipes, and we'll start with a 14-inch, and we'll select standard schedule. And we'll click OK. Compress will then pull the outer diameter and the thickness over for you, as well as provide a little description of the nozzle. So at this point, now that I know my outer diameter, now I would like to go and add a flange onto this. Now you have a choice of adding a V16.5 flange or an Appendix 2 flange. V16.5 flanges are great. They're accepted based on pressure temperature ratings. But what if we can't find that standard flange to meet our needs? Well, what we can do is we can design an Appendix 2 flange. So I'll click Add an Appendix 2 flange right here. I'll click the Copy Last button. So this first screen is similar to what we've seen before, just selecting materials and setting up pressure and temperature conditions. Then we'll click Next. There's a little bit more information with the flange. So to start with, we need to select what type of flange we'd like to use. So let's start with a weld neck integral. And then we can select our facing sketch. So I'll take 1A right. So this will have a raised face. We can then select the gasket description. Compress has a library of flex italic gaskets available for you. So you can select any from the list. If the gasket you wish to use isn't available in this list, really all that's needed is the gasket M and Y factor here. We'll then drop down and select our bolting material as well as the bolting type. From here we'll click Next. And as you can see, here's our picture of our flange so far. Now what we can do is we can change any of the dimensions that we may have. Maybe you like to try to get a thinner flange, so we might want to try to move the bolt circle in, out, things like that. Once we get this set, you just simply click OK, and the flange has now been added onto the end of the nozzle. And how you can tell is you'll see a flange here at the end of the nozzle neck. So far I've built the nozzle assembly, but I haven't located it yet. So let's take a look at that. The location of the nozzle will take place down at the bottom here. And what we'll need to know is first, what component would you like to place this nozzle on? So there's a pull down menu here with all the available components. So let's attach this to cylinder number 3. Then all we need to know is the offset, an angle, and a projection distance. So we'll start with the offset. Now currently this offset is being taken from the top seam of the component. But you can change this if you like to locate everything from the datum line, or from the bottom seam of the component, or from the end of the nozzle. This is really personal preference. So actually let's take this from the bottom seam of the component. So let's put this halfway up. So I'll move it up 48 inches. And then I'll rotate it around the vessel by 90 degrees. Then we come to the projection distance. Now this distance is going to be taken from the center of the vessel to the face of the flange. Now this distance may not always be available to you. Oftentimes you may see a nozzle with an external projection from the OD. If you get that, that's okay. What you can do is under this input, there's a box here that says calculate minimum R from desired external projection length. So we'll click on this and we can type in the projection. So let's say we need it to project 16 inches outside the vessel. So we'll type in 16 and we'll click OK. And as you can see, Compress has calculated what that value needs to be. So this first screen is really just setting up the nozzle. What we're going to do is we're going to click Next and we're going to see if this meets code criteria. So this is the second screen of the Nozzle Dialog, and what you're looking at is a cross-sectional view of the nozzle, and this red dash box here represents our limits of reinforcement. So in the event that we may need to add a reinforcing pad, we'd want to make sure it's within this red dash box or else it's not credited toward our areas. But how do we tell if this meets code criteria? Now, at the bottom of this dialog, there's a status bar, and we list here the area available and the area required. So currently I have about 1.35 squared inches, but I require just over 2.5 squared inches of material. So this nozzle is technically failing code right now. So if you were to click OK, Compress will alert you with this warning. It says opening not adequately reinforced, change the current design. Now this is the one component Compress will not change on you in design mode, simply because we're not sure what you'd like us to change. If you'd like us to bump up the shell thickness, the nozzle thickness, add a reinforcing pad, that decision is up to the designer. But if you do decide to add the nozzle, Compress will limit the chamber MAWP to this nozzle. But I'm going to change it, so I'm going to select yes. And at this point we need to decide how much area do we need. Do we just need a little bit? Can I just order a heavier nozzle neck? Things like that. What I'm going to do is click previous. I'm going to change this to a type 2 and adding a reinforcing pad. So I'll click next. And as you can see, the reinforcing pad has now been added. And I now have more area available than what's required. So this nozzle now technically meets code criteria, but we still need to make sure that this is a feasible design. So maybe we want to make the pad width a bit wider and a bit thinner, maybe to help out on welding. So we can start changing the dimensions of the pad. Like so. Once we get the nozzle set, we can also take a look at any external loadings we may have coming in on this nozzle. In order to do that, what we'll do is we'll click on the WRC local stress button right here. And as you can see, here's a picture of our nozzle with our repad and the loadings per the WRC 107 convention. Compress can also analyze these loadings using the WRC 537 as well. So what I'll do is I'll just put in some loads, like so. Now as I'm typing these loadings in, we're calculating the stresses for you. So you can get an idea whether or not these loadings are going to overstress your shell now and make any changes you may need to. And we'll also provide you a full report for this. So I'll click OK. I'll click OK. And there's our nozzle added onto the vessel. Okay, once we get to this point, maybe we want to run the code calculations and determine or see if there's any problems going on with our vessel. In order to do that, what we'll do is we'll come to our Action menu and we'll select Perform Code Calculations. This is the output report in Compress. Now this is currently being viewed in the HTML version, but we can also convert this to a PDF by clicking on the PDF icon right here. So in the report, we're going to have summary reports available for you, as well as detailed calculations of all the components that we've modeled. So the first thing that we always recommend you do is you check the deficiency summary. Now in Compress, we have what we call deficiencies, but we also have warnings. Warnings are good engineering practice and are advisory warnings. The designer can ignore them if they choose to, or they can make changes based on these. For example, this vessel right here is a warning. It's recommended that a full penetration nozzle to shell weld is used with nozzles with external loading. So that nozzle that I added onto the vessel, I had placed WRC 107 loads on it, so Compress is just warning you, saying you may wish to put a full penetration weld on. The pressure summary will list all of the components that we've modeled, along with the design pressure and temperature, and our calculated pressure, so our MAWP, our MAP, and our MAEP. Then we can get into the detailed calculation. So for example, the cylinder, what we'll do is we'll list all the information here at the top for you, and then Compress will grind down to the calculations. So for example, the design thickness, here's the temperature we took the allowable stress at, along with the applicable code paragraph. So we'll list the code formula, all the values that we used, and the end result. So you have a full paper trail of every calculation that we do. So let's say we're in this report and we'd like to switch back to the model. Maybe we want to try to make the cylinder thickness a bit smaller. So what we'll do is we'll click on the PDF icon and we come back to our model here. The next item that I'd like to show you are the forms. Compress can automatically fill out your U forms, A forms, or your R forms. So in order to do that, you simply click on the Forms menu right here, and we'll take an ASME U form, and we'll select a U1A form. Now when I select this, an HTML version of the U1A form will appear, like so. And as you can see, I've gone ahead and filled out some of the information here. This is all information that we can fill in a default setting, so every time you fill out a form, your information will be populated. How to do that? You'd simply come to the Form menu and select Form Settings. And this Defaults dialog will appear, and you can fill out all of your information. Then, all of the technical information will be populated by Compress. So as you can see, Compress has gone ahead and filled out this form for you. So all you would need to do is fill out the national board number or the CRN number, review the form, add in remarks you or your AI may have, and then click the Generate button at the bottom, and a PDF version of this form will be filled out for you. The last item I'd like to touch on is our 3D solid model export. Compress can now export our models into programs such as SolidWorks and Inventor. In order to do that, what we'll do is we'll click on this 3D button right here, and we'll convert Compress to a true 3D model. From here, we can export the model. Compress can currently export ASIS files, STEP files, IGES files, Granite files, as well as a Codeware XML 3D file. Now this is the file that we would want to use if we wanted to bring it into Inventor or SolidWorks. Codeware has a Codeware interface program that links into these two programs, and this is the file that we would read in. If you'd like more information on our Codeware interface, please feel free to contact us or review our videos page on our website. There are a few videos there that highlight our Codeware interface and how we import the models. But I'll click Save here, and the model has been exported successfully. Thank you for watching this quick video. If you have any questions or would like to see a demonstration, please email sales@codeware.com or call 941-927-2670.